Hello, we are discussing about GATE 2004 ECE paper, and the topic we are discussing is electron devices. Consider the following statements. Statement 1 and Statement 2. Statement 1. The beta of a bipolar transistor reduces if the base width is increased. Statement 2. The beta of a bipolar transistor increases if the doping concentration in the base is increased. Which one of the following is correct? A. S1 is false, S2 is true. B. Both S1 and S2 are true. C. Both S1 and S2 are false. D. S1 is true and S2 is false. Correct answer for this question is D. We will see the details. This is the statement 1. The beta of a bipolar transistor reduces if the base width is increased. So, if base width increases, what happens to beta? Let us assume we are going with PNP transistor. So, a transistor consisting of three terminals: emitter, base and collector. Emitter and collector is of P type and base is of N type. The characteristics of base are nothing but lightly doped and whose width is going to be very small. Area of base is small. These are the two important characteristics. One is nothing but lightly doped, the other is nothing but width is going to be very small. So generally the collector width is going to be large compared to emitter width compared to base width. Since base width is going to be small, as the charge carriers are moving from emitter to collector, they are going to be flowing through base, and in base you will get very little recombinations. If the base width is going to be made further small, at that time the number of recombinations in the base is going to be still reduces. So maximum number of holes from P type emitter will go to P type collector. So IC is approximately equal to IE. It will become as base width is going to be reduces. So now look at this one. As WB reduces, WB means width of base. As base width reduces, number of recombinations in the base is going to reduces. So maximum holes from emitter to it will reach collector. So collector current is approximately equal to IE, that is IC by IE. The ratio is going to be increases. IC by IE is nothing but alpha. Alpha is nothing but common base DC current gain. And whenever alpha increases, common emitter current gain also increases, that is beta. Beta is increasing. So when alpha increases, beta increases. Beta is equal to alpha by 1 minus alpha. So as WB reduces, beta increases. Otherwise, if WB increases, beta reduces. So the statement given is the beta of a bipolar transistor reduces if base width is increased. So this is true. If base width increases, beta reduces. So statement 1 is true. Now we will consider statement 2. Statement 2. The beta of a bipolar transistor increases if the doping concentration in the base is increased. So with respect to doping, emitter is heavily doped, collector is moderately doped and base is lightly doped. Since base is lightly doped, as the charge carriers are moving from emitter towards collector side, they are going through base, and in that base, since it is lightly doped, very less number of recombinations are taking place. If we are increasing the doping concentration of base, at that time number of recombinations will be more. Number of recombinations will be more implies nothing but effective number of holes reaching collector are going to be less. So the ratio IC by IE is going to be reduces. We know that one base is lightly doped, but if base concentration, we are indicating it as NB. N is used for the carrier concentration, B implies nothing but base carrier concentration. If base doping concentration is going to be increases, by that time number of recombinations in the base increases, so that effective number of holes reaching from emitter to collector reduces. So IC by IE reduces. The ratio of IC by IE is nothing but alpha. So alpha reduces. When alpha reduces, beta reduces, since beta is equal to alpha by 1 minus alpha. So that as doping concentration increases, beta has to be reduced. But in the statement, beta of a bipolar transistor increases if doping concentration in the base is increased. So the statement is wrong. Statement 2 is false, whereas statement 1 is true. So the correct answer for this question is D. Statement 1 is true, statement 2 is false. Thank you.